So let's go to France, let's go to northern Spain, and look at those Solutrean artifacts and see how they really might relate to Clovis. Now, what we found even surprised us. This is a typical Clovis point. Here is a not particularly typical Solutrean point, but a type of Solutrean point that only occurs in the Franco-Cantabrian area.
Ironically, in the only region where concave base points of Solutrean age purportedly most like Clovis points are common, the eastern half of Asturias and the western half of Cantabria in northern Spain, large blades are in fact very rare due to raw material constraints. In this region, good quality flints occur only as small nodules, so the production of the uni and bifacial points is based primarily on the use of quartzites and poor quality cherts.
What the authors are pointing out is that Solutreans only show smaller concave-based points in regions where the material was restrictive. This material restriction did not exist in the Americas, yet we do not see the more common larger laurel leaves anywhere in the Americas. More importantly, even the smallest Solutrean point is not as small as the largest Clovis, and when the comparison is done with the correct candidate, pre-Clovis, the difference is even more abysmal. No triangular points, and definitely, no laurel leaves.
It must be noted that the frequency of large blades and large blade cores in Clovis is highly spotty and hardly typical. Large blades occur in assemblages in the south-central United States, for example Aubrey and Galt sites, Texas, Carson Conshort, Tennessee, but are extremely rare, if not altogether absent, in assemblages from the rest of the continent, including eastern North America.
And we found in at least 2 sites potentially fluted points.
I find it interesting that he would show a drawing, if these were as clear as he claimed. Of course they never saw the points, they made the claim off of a 1963 book. This was what Strauss had to say.
Clovis points are almost always fluted on both faces. Again, to give a specific example, 92% of 421 Texas Clovis points for which data are available are fluted on both faces. Solutrean points, of course, are not fluted. Bradley and Stanford dismiss fluting in Clovis as nothing special, merely part of the thinning process. This is a curious claim given the ubiquity of this feature in Clovis, and its nearly universal absence in all other North American lithic assemblages, save those of Folsom groups who immediately followed. But perhaps they advanced this line anticipating the problem posed by the absence of fluting in Solutrean points and, more critically, in pre-Clovis assemblages. Yet, oddly, they still cite fluted biphases occurring in Solutrean as supporting evidence of a historical connection. However, the pair of stubby, convex base foliates with possibly accidental basal flake removals from La Haute in Dordogne, France, published by Smith, 1963, are no more relevant than the isolated Siberian finds criticized by Bradley and Stanford.
Well, that's kind of cool. 21.9, 19.5, that's cool. Then we found that the core and blade technology, revolving around 3 types of cores, wedge-shaped cores, conical cores, and smaller circular cores, occurred, and manufacturing techniques were the same. That's getting a little exciting. In fact, by the time we put our database together, we found that there were 32 almost perfectly good comparisons or fits between Clovis and Solutrean. In Siberia, and all the work that my colleagues and myself have done in the Beringia, Siberia, Eastern Asia, if you find one of these technologies at any one time period, you've done a major find, because they just do not exist. Every now and then you see something. You can make up a list that you can match these in Siberia.
Interesting claim. But Strauss's study indicates otherwise. He did the exact list Bradford is claiming could not be done. Of Bradford's own list of traits, they found 22 matches. So much for his claim.
Bradley and Stanford argue that early sites in Siberia and Beringia do not contain a lithic technology that remotely resembles anything we would be expecting as a precursor to Clovis. Even a cursory review of the published literature on the Siberian and Beringian Upper Paleolithic, however, shows the shallowness of this claim. In Table 1 we present the list of traits used by Bradley and Stanford to compare Clovis and Solutrean, and we consider the presence-absence of these traits in the Siberian Upper Paleolithic generally, and at the Ushki, Tanana and Nenana sites specifically. Consider first the Siberian Upper Paleolithic. All but 3 of Bradley and Stanford's Clovis traits have been reported from a sufficient number of Siberian sites to be considered common. Features that are rare are limited to intentional overshot flaking. We can find only 2 instances of this technique, Ustkova and Barelek, and double Barevelt osseous rods, which to our knowledge have been recovered only from Yana. The single feature that is absent is incised stones. However, such artifacts have been found in the post-Clovis age layer 6 at Ushki 1 at 10,400 carbon 14 years BP. Now consider the Beringian, Nenana, Tanana and Ushki complexes. All 3 of these complexes contain elements of biface reduction and blade technologies. For example, Nenana and Ushki have basally thin points and bifaces, examples of pressure flaking and unifacial tools made on biface thinning flakes. Further, Ushki has several very thin bifaces with invasive flake scars grating on being outrepass. Even the small Tanana-lithic assemblages contain many biface thinning flakes and a few bifaces. In addition, some tools in the Nenana, Tanana, and Ushki assemblages are made on blades, but blade cores are virtually absent. The lack of large, elegant bifaces and blade cores in all of these Beringian industries probably has more to do with lithic raw material constraints than anything else. Nearly all retouched tools found in the early Nenana, Tanana, and Ushki assemblages were produced from small cobbles or pebbles of fine-grained lithic material procured from local alluvial or glaciofluvial deposits. Nonetheless, a quick scan of Table 1 indicates that these Beringian complexes in fact do share many of the lithic aspects of Clovis. Missing, however, from the Nenana and Ushki sites is an ivory, antler and bone industry. Faunal remains are absent from these sites, too, indicating that this is a preservational, not cultural, difference, and thus akin to the situation Bradley and Stanford describe for Clovis. Yet, at the Tanana Valley sites where faunal remains are well preserved, so are bone and ivory artifacts. Although the total number of osseous tools recovered from the Broken Mammoth, Mead and Swan Point sites is still small and most come from latest Pleistocene deposits, Cultural Zone 3, that postdate Clovis by about 500 years. Worked pieces include ivory points and rods, a possible idle handle and eyed needle. Taken together, the early Nenana, Tanana and Ushki complexes document not only that Upper Paleolithic humans were present in Beringia during and just before the time of Clovis, but also that these humans tended to manufacture stone tools from bifaces, biface thinning flakes and blades. Further, they produced osseous tools similar to those from Clovis sites in mid-latitude North America. We agree with Bradley and Stanford that there are technological and typological peculiarities that distinguish these industries. There are even differences within the Beringian complexes presented here. However, we disagree with their interpretation of these differences. We argue that many of the specific differences are behavioral and adaptive, not culturally normative, and that the general similarities indicate a link between Clovis and the Upper Paleolithic of Northeast Asia. Unlike the Solutrean and Clovis archaeological records, both of which are reasonably well known at this juncture, the archaeology of late glacial Northeast Asia is not as well known, and thus dismissing it as an origin point of the first Americans is premature. Given time, we are confident that the answers we are searching for are going to be found in Alaska and Siberia, not Europe.
Or more likely, farther south in Asia, as the landing points would be underwater, based on the coastal route migration.